Alright, question 2. So this is a past year paper from paper 41 May June 2020. Alright, but this question is like considered a basic one. It's not like very difficult. Okay, so so let's start with like the basic one. So a particle move in a straight line AB, the velocity t after leaving A is given by this equation where k is a constant. So the displacement of the particle from A in the direction towards B is 2.85, and when t equals this is when t equals to 3, and is 2.4 when t is equal to 6. Okay, so which means we have a straight line AB. Alright, so you can just assume that your find the value of k. So find an expression in terms of t for displacement of the particle from A. So basically this would be your reference point lah. Okay, so displacement of the particle from A in the direction towards B is 2.85. So which means from A in the direction towards B is 2.85. So which means maybe it's like roughly here. Okay, so t equals to 3 is here and the s is 2.85. Then after that, what happened here is when t equals to 6, it eventually comes nearer. So t equals to 6 is only 2.4. Okay, so that's the idea. So the question wants us to find the value of k and find the expression in terms of t for the displacement. So which means by using this, we know that we need to like form some equation and we need to solve the equation so that we can get the value of the constant that needed. Okay, so let us try to write down first the information here. So which is v is equal to k t square minus 10t plus 21. Okay, for the question that it involve integration, right, I'll prefer that you can, leave your equation like this, so which means you doesn't need to actually expand it, yeah, because you already know that you can take out your k later while doing the integration. So that's why we need to solve the expression for displacement. So s is equal to integrate v with respect to t, right? Then equal to, so from here then I'll be able to get k, then t square minus t 10t plus 21. Okay, so from the rules that we learned previously, we can definitely take out k. Alright, so now we can start our integration. So k, and then we have t cubed over 3 minus. Okay, so you might have a question here. Do you need to put your c inside or put your c outside? Okay, so the idea is that c is a number, right? It's a constant. Then okay, if let's say I put a c here, then later when I try to expand it, then I'll be able to get ck. So k and c together is also a constant, right? So which means to ease our calculation, basically you can just put your c outside, because that's definitely going to represent your k a. Like for example, if I put a inside, so k multiplied by a, then isn't it I'm getting another constant which I can represent it by another constant here. Okay, so I hope that you still remember this part from what you have learned in Pure Maths 3. Okay, so yeah, that's the idea. So which means we can try to use the information here to help us to solve. So the first one is when t equals to 3, then we have s is equal to 2.85. Okay, so 2.85 is equal to k, then we substitute 3 square divided by 3 minus 5 3 square plus 21 3, and then plus c. Okay, so from here then I can continue to solve it. Then I can get 2.85 is just equal to k times 27 and then plus c. So my first equation to tell me that I have 27k plus c equal to 2.85. Okay, then when I continue, then I will substitute the other one lah. So t equals to 6 and s equal to 2.4. So similarly, just substitute all right, plus c. Then after that, you can actually rearrange it. So 2.4 equal to k and is 18 here and plus c. So 18k plus c is 2.4. Then I'll be able to get my second equation. Okay, so we with these two information that I can actually solve simultaneous already, right? So I use first one minus the second one, then I can get 9k is equal to 0.45, which gives me my k is 0.05. And you actually solve the first part, which to find the value of k. So now you need to write an expression in terms of t for the displacement. So which means we still need to write the whole thing here. So which we need to find our c as well. So you can just use either one. So 18 0.05 plus c is equal to 2.4. So from here that I can get that c is equal to 1.5. Okay, so now we can just substitute and write our expression. So s is equal to 0.05 and then t3 over 3 minus 5t squared plus 21t and then plus 1.5. So you can imagine that if let's say your c is put inside the bracket, right, then by the end then you can just going to, what do you say, expand it, or actually you put your answer inside, it wouldn't be wrong as well. Okay, but the easier way is just put it outside lah, because there's no, I mean, it's not compulsory for you to do the factorization and so on. Okay, so yeah, for B, so find the displacement of the particle from A where the velocity is a minimum. All right, so we can find when will the velocity be minimum first. So V is minimum when our dv dt is equal to 0, right? Yeah, so this is a combination of integration and differentiation together in one question. So yeah, when dv dt equals to 0, so now we need to solve for dv dt equals to 0. All right, so yes, you can just, if let's say you think that's easier, then you can just try to expand it first before you move on. Yeah, so we have v is equal to 0.05 and then t squared minus 10t plus 21, and yeah, okay, so that's our velocity, right? Because we have found k already, so you can just expand it first. All right, so now we can straight away continue our differentiation. So when we differentiate it, then I'll be able to get 0.1t minus 0.5 equals to 0. All right, so from here that I can get 0.1t is equal to 0.5, which will give me my answer is t equals to 5. So when my velocity is a minimum, oh yeah, so I hope that you have saw the correction in the post, right? So when we talk about when the yeah, I think I made a mistake in the previous lesson, which I talked about like the maximum and the minimum velocity. Yeah, so it makes no difference if let's say we talk about the speed is a maximum, because the minimum velocity will eventually become the maximum speed. But then when we talk about velocity, that's still positive and negative, right? So that's why the positive side, the largest number is the maximum. Then the smallest number in negative will the largest number in negative, meaning the most negative number, will be the minimum. Okay, so that's why it's going to be dv dt equals to 0 as well. Okay, so when you try to continue to solve it, so meaning when t equals to 5, you have your minimum velocity, and now we try to find our displacement. So by using the expression that we got just now, so which is the s, that one, yeah, this one, okay, then we substitute our t. Okay, so we have s will be equal to 0.05 and then substitute 5. So 5 cubed over 3 minus 5 square. Okay, I'll continue here. So plus 21, 5 and then plus 1.5. All right, so we can continue to solve 0.05, 65 over 3 and then plus 1.5. So from here, then I'll be able to get answer 27 over 13. Okay, so that's in meter. Alright, or if let's say you want to write decimal point also can, so make sure in three significant figure lah. So 3SI. Alright, but the much more preferred answer will always be the fraction because that's much more accurate, right? Okay, but yeah, if let's say you cannot round it off to a fraction, then only you try to write the decimal, okay? Because we do not want our answer to, if let's say you are going to use this number for CD and so on, right? Then the accuracy will definitely be higher for when you try to write it in fraction rather than the rounded decimal. Okay, so move on to number three. All right, number three. So this is a multi-stage problem. So yeah, I'm putting in to actually show you the difference between answering like the normal question and this kind of question. So basically, it's that they have different velocity function when you try to deal with different time frame here. Okay, so that's why it will be kind of like much more challenging if let's say you are finding the total distance because you need to imagine that which means for different time frame you need to integrate different function here. Okay, so that's the idea. All right, so let's try to look at A. So a particle move in a straight line, so the velocity at time t is given as below. So sketch the velocity time graph from 0 to 1 13.5. So which means that you might have like three different line for these three different cases. So it will be easy for us, like for example, it can definitely see that for the first one and the last one is going to be a straight line. All right, so you can just like finding out what is the point for t equals to 0 and t equals to 5, then you can draw a straight line already. Then the much more complicated one will be the middle one because it's a quadratic. So which means it's very helpful for you to understand what kind of graph you will get, then how are you going to put them together in this picture. Okay, so let's start with the first one. So A. Okay, so I'm going to show you like full step here, but in the reality, you do not really need to like write everything out because this question is just three questions. So what is important is to show all the important point inside your graph. Okay, so it means by having this for v equal to 2t plus 1. Okay, let me try to solve for 2. So when t equals to 0, then I will be having v equals to 1. The second one is when t equals to 5, then I'll be having v equals to 11. Okay, then for the second one is this quadratic, so v equal to 36 minus t cube. Sorry, minus t square. Okay, so similar, so t equals to 5. So from here, then I'll be able to get v equals to 11. So you can see that this is a continuous graph. So where it ends at the previous stage is how it's where it starts for the second stage. Okay, then after that, t equals to 7. All right, then I substitute and I get v equals to negative 13. Okay, so just by using the interval that's given. All right, then after that, you might think that this is a quadratic, so it will be helpful for us to later solve out how's the graph look like. So the third one is v equal to 2t minus 27. So similarly, substitute 7. Okay, then after that, check the v. So the v here is going to be negative 13 as well. Okay, so that's why it's a continuous here also. So t equals to 13.5 and I can get v equals to 0. So you can imagine that at the end of the graph, it will come back to the x-axis. Okay, so now let's try to plot the graph. So maybe before that, let's try to solve this a bit. So v is equal to 36 minus t squared, right? So we know that it's going to be a quadratic graph and then the graph will eventually like this because negative, right? So we can try to just find some important point here, which if let's say we try to do completing the square, so I'll get negative 1 t square minus 36. So when I continue to solve it, then I can get t negative 1, then t minus 0 square. Take out, then I have plus 36. So which means for this one, I will definitely going to have a maximum point is at 0 and 36. Okay, and just by looking at this one, I know that when I try to solve here is 0, right? Then I'm going to get when v is equal to 0. then my t is actually going to be 0 and 6. Sorry, it's going to be -6 and then +6, but my time cannot be -6, so that's why it will just cross my graph at 6. Okay, and this information is important because I know that I have t equals to 5 is v equals to 11, right? And t equals to 7 and is v equals to -13. So I know when the time when it will pass through the x-axis is definitely going to be at 6, okay, which is aligned with what I have here. Okay, so now let's try to draw the plot the graph. So yeah, you can see the minimum you have is -13, the maximum is -11. So which means your graph should consist of positive and negative. Sorry, let me try to make a much more straight one. All right, so yeah, I'll have this line. All right, then I'll just draw like this. Okay, so we need to have 1 here. Okay, then perhaps this is our 11, and then this is -13. Okay, so some important time where you need to state here, it will be your t equals to 0, then v equals to 1, right? Then t equals to 5, then v is 11. So maybe you try to plot here. So this is 5. Okay, so it is at 11 here. All right, then after that, we know that the graph will actually reach 6, right, later. So it's here, so 6. All right, from the result that we have here. So when t equals to 6, v is equals to 0. Then after that, t equals to 7, then v is -13. So here 7, so -13 is here. Okay, then after that, what we have, then 7, -13 we have already. Then the last one, it should be the 13.5, and the v is 0 is here. Okay, so for the first point, it's just going to be easy, yeah, because it's just going to be a straight line, right? Gradient positive, so that's why you are just getting this line. Okay, sorry, please try to use your ruler to draw. You need to indicate that it's a linear graph. Okay, so yeah, it's a straight line. Okay, then after that, for this one, it's going to be a quadratic, right? So when you try to look at this, then you know that for this graph, right, where is what is that called? Your maximum point is at 0, 36. So which means if let's say I'm trying to draw it, then it will be actually look like this. Am I right? So this is where it touches your -6 and then 6. So this is the point where it touches your 36, right? So the graph shape will eventually look like this. So that's why when you try to connect here to here, then it will be a quadratic shape kind of graph. So it's like it's not going to be like a very straight one. So you need to show the curve part. So sorry, I think I'm drawing it a bit near, but the idea here is you need to have like a bit curve. Okay, so yeah, perhaps you try to move it a bit. Sorry for that. Okay, so yeah, that's the idea. So it must pass through your 6 here. All right, then this is 7. So make sure this is not a straight line. It's like this one, then you are actually drawing this part. Okay, so that's the idea for this line. It's not a straight line. Maybe I draw it a bit straight because of my interval here. Yeah, so make sure that it's going to be like you no, the idea is just that make sure you don't use your ruler to draw it, and you don't draw it like too straight. Okay, so yeah, then after that, the last one is 13.50, so it's here. So this is going to be a straight line, so just use a ruler to connect it. Okay, so the graph will eventually just look like this. So this is v, then this is t. All right, so that's the part for A. So I hope that you can understand how we come up with this graph. Then after that, B, find the acceleration at the instant when t equals to 6. So when you try to do this, then you need to check the time frame. So t equals to 6 is under this interval, right? So that's why we need to use this velocity function. So for V, for t equal to 6, okay, our velocity is 36 minus t squared. All right, so that's why if let's say we want to find A, then which means we will need to do differentiation. Okay, so by solving this, then I can get -2t, then substitute t equal to 6, then I'll be able to get A equal to -2 multiply 6, and that gives me -12 ms per second. Sorry, meter per second. Okay, I think this is quite easy. Yeah, the part that you need to understand is to use the correct velocity function only. Okay, so now for C, find the total distance traveled by P in the interval from T 0, 5, and 7. Oh, sorry, from T of T from 0 to 13.5. So which means you need to use all this. Okay, so this is a question will show you how important the definite integral is, because if you are not using that, right, imagine that, which means for each of these you are going to find all the different expression, then you substitute each individually, then it will take you a very long time. So that's why for this question it will be easy for us to just use definite integration to actually help us to solve it. Okay, so the total distance traveled by P. Alright, so we can always use our graph just now to help us to solve. Okay, so the first stage that we have is going to be 0 to 5. And by looking at this graph, then we know that 0 to 5 is all above the x-axis. Am I right? So that's why all the area here is positive. So I don't need to do any modulus, or I don't need to split the integral, because there's no change in direction happen. Okay, so that's why for the first one is very direct. So which means it's from 0 to 5, and the function that I'm going to integrate is just 2t plus 1 with respect to t. Okay, that's the first one. So now we move on to the second one. It's the second stage here from 5 to 7. Okay, so this is the problem. So 5 to 7 is like from here to here, right? So you can see there's a, okay, this is supposed to be 6. So yeah, there's a positive area here and there's a negative here. So this is the part where we need to split our integral. Okay, so I hope that you still remember from the previous example, because we are finding the total distance. So we must make sure that we have exactly how it moved along the journey, but not the change in the different position only. So that's why in this case, then the first one that I need to split is for 5 to 6. Okay, so 5 to 6. So this is the part that will still give me positive answer. So that's why from 5 to 6, and then 36 minus t squared dt. Okay, then move on to the this part. Okay, so I will have the negative side here, right? So that's why I'll need to modulus my answer. So this is from 6 to 7, and then it's 36 minus t squared as well. All right, so now we are in the last part. So for last part is going to be 7 to 13.5, right? So there's no positive and negative both involved. So which means we can straight find it in one shot. It's just that the answer is negative. So that's why we need to modulus our answer. So plus another one is 7, 13.5. Okay, so this is 2t. Yeah, I'm sorry, I need to write a bit smaller here. dt. Okay, so that's the idea. So I mean, of course, you can try to combine these two, because when you have negative number plus negative number, then you are getting a negative answer, then you modulus all them together also can. But you want to split them also can. So the idea is just the same. It doesn't matter. Okay, and yeah, actually by writing this, right, you are actually having 2 marks for this question already, by having the correct limit and you try to apply the correct function here. Okay, so after we did that, then the next step is to integrate it. Okay, oh, I'm just rewriting here, yes, because I feel it's a bit messy just now. Okay, so now we can start the integration. So which means we are going to have t square plus t, okay, and then 0, 5, and then plus, so for this one is 36 t minus t cubed over 3, 5 to 6. Okay, and then plus, so you see I put them together, yeah, to show you that actually it's just the same, because negative plus another negative, then you modulus it straight away together. Okay, so for this part, just modulus, then the first part is going to be 36t minus t cubed over 3 as well. 5, sorry, this is 6 and 7. Okay, then after that, the next one is going to be plus, and then t squared minus 27t, so 7 to 13.5. Alright, so by having this, then now we can try to solve it. When you try to look at this kind of question, right, it's not compulsory for you to actually substitute everything inside, but you also cannot straight away get to your last answer. So which means what I will actually recommend you to do is you can just write down your answer after substitute. So for example, when I substitute 5, then I know that I'm going to get 25 plus 5, right? So that's why I can straight away write the d and then minus 0. So that's the first one. After that, the second one, then I try to substitute my 6. Then I know that I'll be able to get 144. So I'm just writing down 144 and then minus 138, then 1 over 3 for when I substitute 5. So that's the idea. Okay, and plus modulus. So this is the part where I substitute 7. So I can get 1, 3, 7, 2 over 3, and I substitute 6, so which is going to be the same thing here, so minus 144. So you can remember to check that this is certainly going to give you a negative number. If you are not getting a negative number, meaning something wrong already. Okay, and plus, so same thing, substitute 13.5. So we'll be able to get negative 1 over 4. Then minus, then substitute 7 is negative 1 for substitute 7 is negative 140. Okay, so by having this, then I'll be able to solve it modulus. Alright, so the front part I will have 30 and then plus 5, 2 over 3. Okay, so modulus negative 6, 1 over 3 minus 42, 1 over 4. So you can imagine if let's say I try to split them out, then it's going to give me the same thing as well, because positive number plus another positive number, then it's the same with I plus these two together and I do modulus lah. Then it will be equal to 84.25. So this is exactly 1 over 4. So it's okay if you, let's say you want to write decimal. Okay, so please make sure that this one you cannot round it to 84.4 because this is an exact answer. You only can round it off if it's a non-exact answer. So which means your answer cannot actually change it to fraction. Okay, so for non-exact answer only you can round it off to 3SF. So for this one, because it's basically 84.841 over 4. Okay, so the safest way is to just always write it in fraction lah, if you can. Okay, if for the question that is not a fractional number, then I mean it's not a rational number, then you have to write in decimal. Okay, so that's the part for this question. So now move on to the last one. Alright, the last question. So a particle move in a straight line. It starts from rest at fixed point O on the line. So the acceleration at time t after leaving O is given this function. So yeah, this is a question that, because for the previous question, we are mainly focused in the velocity function, after that to find the displacement. So this is from acceleration. Then later, I think you will need to solve for both velocity and also displacement. Okay, so yeah, number one, show that in the subsequent motion, the acceleration of the particle, so which means that you are going to find, show that in the subsequent motion, the acceleration of the particle when it comes to the rest is 16. So which means that from this information, right, what do you have is, the question said that you need to show that when it comes to rest, so which means when v equals to 0, you can prove that your A is basically equal to 16. Okay, when the particle come to the rest, which is v equals to 0 and the acceleration is 16, so A is 16. Alright, so from here then, which means that we might need to get an equation, or we need to get to the variable that we can try to compare these two together. And we know that definitely there's no, because we are talking about what is that called, variable acceleration. So we do not have like one equation that involve both v and a together in the same equation. So that's why the only variable that these two equation can share is the time. So which means that for me to prove this, I can find actually what is the time when t equals to 0. Then after I get the time, then I substitute into the a function, then I'll be able to get I will be able to prove that the A is 16. Okay, so which means that what do I need to do first is to find the function for velocity first. Okay, so A is 0.4 t power 3 minus 4.8 t1 over 2. Alright, so which means I will have v is equal to integrate my function for a with respect to t. Okay, so after I have this, then I can start my integration. So yeah, let me just write it first. Okay, so now we can try to integrate. So plus 4, so 0.1 T4 minus, so 3 over 2, so 4.8 divided by 3 over 2, and we can get 3.2 T 3 over 2 plus C. Okay, don't forget this. Okay, so now we need to have one information regarding to T and V so we can solve our C. So when you try to read through the question, we know that it starts from rest at the fixed point or on the line. Okay, so that's why when it is at the fixed point, right, when time is equal to 0, it actually starts from rest. So that's why when t equals to 0, v is basically 0. Okay, so by substituting this, then we can actually get 0 is equal to 0.10 power 4 minus 3.2 and then 3 over 2 plus c. And that will give us our c is equal to 0. So now we have our equation for v, which v is equal to 0.1 t4 minus 3.2 t power 3 over 2. Okay, so the next step is we have this equation already, so we can always find what is our t when v equals to 0, right? So when v equals to 0, then what is our t? Alright, so 0.4 T4 minus 3.2 T3 over 2 is equal to 0. So when you try to solve this, then you need some skill that you learned in indices already. So which means T4 and T3 over 4, so you can take out T3 over 4. Alright, then 0.1 and 3.2, I think you can take out 0.1. Okay, take out the smallest common factor that you have. Okay, so for 0.1, which means you only need to multiply by 1 lah, then after that t. So what do you look? So we know that when you have two indices and you multiply them together, it's basically the power plus together, right? So this is 1.5. So 1.5 need to plus how much so that you can get 4? It's 2.5. So that's why it's 5 over 2. Okay, then after that minus, so 0.1 and 3.2, I'll need to multiply 32. Alright, then after that t3 over 2 is the same thing, so nothing else equals to 0. Okay, so from here then I can solve. The first one is 0.1 t 3 over 2 is equal to 0, so that one will give me basically over that I get 0, so t is going to be 0 lah. Alright, then after that the second part is t5 over 2 minus 32 will give me 0, so that's why t5 over 2 equals to 32. So when you move this, so which means that how do you get t is that you will square your answer, right? Okay, then after that root to power of 5. Alright, okay, I still remember, I hope that you still remember how to do this, or basically you use 32 to the power of 2 over 5 also can. That will just give you the exact same answer. So because of your t is always positive, so this is, what is that? An odd number, the root in odd number as well, so you will have only one answer lah, so equal to 4. Okay, so which means that we need to come to another rest, right? So that's why t shouldn't be equal to 0 anymore, so t should be equal to 4. Okay, so now we need to prove that when the time, so at time equals to 4, our v is equal to 0. Okay, so the idea is when t equal to 4s, our v is equal to 0. So which means that at time equals to 4s, we need to prove that our a is equal to 16. So a will be equal to, just substitute the 4 in the acceleration function. So 4 power 3 minus 4.8, 4 to the power of 1 over 2. Alright, so I'll be able to get 25.6 minus 9.6, which give me my answer is 16 meter per second square. Okay, so proved. Alright, so yeah, that's the idea for this question. Okay, so yeah, I hope that you can understand it. So now let's try to look at part 2. So find the displacement of the particle from O at t equals to 5. Okay, so this is only displacement. So that's why we do not need to actually know whether the area will be at positive side or negative side, right? Basically, just to solve this. So again, this is very important. So for this question, it's important for you to see the how definite integration is important, because you might do not want to actually find out s, then you substitute. So which means you can straight away solve the integration. So s, okay, the displacement at t equals to 5. So the s will be just equal to what is the change of the displacement when you try to compare it from the original point at 5, right? Because from O is basically when t equals to 0. So v then dt. Okay, so we already have our v function here that we got just now. So this one, all right. So we are just going to substitute it now. So s will be equal to 0.5. So substitute 0.1 t4 minus 3.2 t 3 over 2 dt. All right, so yeah, we can actually start our integration. Okay, so 4 then plus 1, so I have 0.02 t to the power of 5, and then minus, so another, so 5 over 2, so 3.2 divided by 5 over 2, so that's 1.28. So t to the power of 5 over 2. I'm going to substitute 0 and 5. Alright, so yeah, by doing that, then now we can just substitute. So 0.02 substitute 5 minus 1.28 substitute 5 to the power of 5 over 2. So when you substitute 0, then yeah, you know that you are going to get 0 lah. So minus 0. So this is the first one. This is the second one. Okay, so now we can just continue to solve it. Then you can get 62.5 minus 71.554 and so on. Okay, then after that your answer will be, yeah, this is not a answer that I think because of square root 5, it's not a rational number. So that's why when you try to write your answer, you can only write it in decimal. So negative 9.05417 and so on. Please make sure that for this one you are pressing the whole thing. So equal to negative 9.05 meter for 3SF. Okay, so that's the part for the past year question. So I hope that you can understand it and spend some time to do your homework. So yeah, that's it for today's lesson. Thank you.